Hello everyone, today we will discuss a new topic, complex numbers and quadratic equations. We have learned the general form of quadratic equation, ax square plus bx plus c equal to 0, where a not equal to 0. So the solution of this quadratic equation is x equal to minus b plus or minus root of b square minus 4ac divided by 2a. This b square minus 4ac is called discriminant. So here we can take d is equal to b square minus 4ac. If d greater than 0, the solution of the quadratic equation is real and distinct. If d equal to 0, the solution of the quadratic equation real and equal. Okay? If d less than 0, there is no real solution. There is no real solution. So we extend the real part to imaginary solution. So if d less than 0, then the solution of the quadratic equation is a complex number, that is an imaginary number. So here we get an imaginary number, where b square minus 4ac part less than 0, the solution of the quadratic equation is an imaginary number. We have already seen that if x square plus 1 equal to 0, then we get here x square equal to minus 1. We know that the square of any real number is a positive number. Here x square is equal to minus 1. So here we get x is equal to root of minus 1. So Euler, the scientist Euler, introduced the imaginary number, that is iota. Or simply we can write this I means I is equal to square root of minus 1. This value is called I square root of minus 1. And we get here I square is equal to minus 1. To solve this type of equation, that is this equation and similar type of equation, we will use the complex number or imaginary number. So the value of I is equal to root of minus 1 and I square is equal to minus 1. So a complex number generally denoted by z. If z equal to x plus iy, so here x and y are real numbers. X and y are real numbers and x is the real part of the z, real part, and y is the imaginary part of z. Imaginary part of z is y. So we can write this z also, z equal to x y, ordered pair of x y. So x is the real part and y is the imaginary part. If two complex numbers, two imaginary numbers or two complex numbers are equal, that means if we can take z1 is equal to a plus ib and z2 equal to c plus id, then if z1 equal to z2, then we can say a equal to c and b equal to d. And z bar, if z equal to x plus iy, then z bar is called complex conjugate. Then z bar is equal to x minus iy. When we add z with z bar, then we get z plus z bar is equal to x plus iy plus x minus iy, that is 2x. So that implies z plus z bar divided by 2 is equal to x. That is real part of z. X is the real part of z, and here we get the real part of z is equal to z plus z bar divided by 2. When z minus z bar is equal to x plus iy minus x plus iy, so that is 2iy. So that implies z minus z bar is equal to 2iy. So z minus z bar divided by 2i is equal to y. Y is the imaginary part. So here the imaginary part of z is equal to z minus z bar divided by 2i. So when we add the complex conjugate with the complex number, we get the real part of the complex number, and when subtract from z to z bar, we get the imaginary part of z. If z is equal to x plus iy, x is the real part and y is the imaginary part. If x is equal to 0, if x is equal to 0, then z is equal to iy. So here z is a purely imaginary number. Purely imaginary number. If y is equal to 0, then z is equal to x. That means z is a purely real number. So whenever we'll take a complex number that is in form of x plus iy, x is a real number and y is also a real number. X is the real part of z and y is the imaginary part of z. Now we'll start algebra of complex number. Here we will discuss the addition, difference, multiplication and division of complex numbers. So let us start addition of complex number. Addition of two complex number. If z1 is equal to a plus ib and z2 is equal to c plus id. Here a, b, c, d are real numbers. So then z1 plus z2 is equal to a plus ib plus c plus id. So here we get a plus c, that means addition of first two real part, plus I whole into b plus d, means addition of two imaginary part. So here we get the addition of complex numbers. So here it satisfies, addition rule satisfy the closure law of addition. That means addition of two complex number is another complex number. Okay, so if z1 is a complex number and z2 is a complex number, then we get here z1 plus z2 is another complex number. Similarly, we can define the associative closure next commutative of complex number. That means z1 plus z2 is equal to z2 plus z1. If next property, associative rule. If z1, z2, z3 are three complex numbers, then it satisfies the associative rule. That means z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. Now we will discuss discuss about the existence of identity under the addition rule. So here the existence of identity means we get here 0 plus I0 is equal to 0. This is the additive identity of complex numbers. That means if we will add 0 with a complex number, then we get here z. So 0 plus I0, that is 0, is called identity of the complex number, additive identity. Next, come to the additive inverse of complex number. When z is equal to a plus ib, we will take minus z is equal to minus a plus minus ib. So here minus z is called the additive inverse of z, and z is called additive inverse of minus z. That is z minus z is equal to 0, where 0 is the additive identity of the complex number. Similarly, we can define the difference of two complex numbers. That is, when z1 is equal to a plus ib and z2 is equal to c plus id, then z1 minus z2 is equal to a plus ib minus c plus id. So here a minus c plus I whole into b minus d. So we subtract from first real part to second real part, plus I whole into b minus d means subtract from the imaginary part from first real number to second real number. So here we get the difference of two complex numbers. Now we will discuss the multiplication of two complex numbers. If z1 is equal to a plus ib, z2 is equal to c plus id, here a, b, c, d are real numbers. So z1 into z2 is equal to a plus ib whole into c plus id. Here we get a is multiplied with c plus id, that is ac plus aid, plus ib is multiplied with c plus id, so here we get ibc plus I into I square is equal to minus 1, so minus bd. Now separating the real parts and the imaginary parts, we get here ac minus bd. This is the real part of the multiplication of two complex number z1 into z2, plus I whole into ad plus bc. Now here we get the imaginary part of the two complex number, multiplication of two complex number, that is z1 into z2. For example, if z1 is equal to 1 plus 2i, z2 is equal to 2 plus 3i, we get z1 into z2. Simply we will take this formula, ac minus bd. A is 1, c is 2, minus b is 2 into d is 3. So ac minus bd is the real part of z1 into z2, plus I whole into ad. A means 1, d means 3, plus bc, b is 2 into c is 2. So now we get the value, that is 2 minus 6 is minus 4, here plus 3 plus 4 is 7i. So now we get another complex number. If z1 is a complex number and z2 is another complex number, then we get here z1 into z2 is another complex number. So it satisfies the closure law of multiplication rule. Multiplication rule also satisfy the commutative law. That is, if Z1 and Z2 are two complex numbers, then Z1 into Z2 is equal to Z2 into Z1. Similarly, when we take three complex numbers Z1, Z2, Z3 is satisfy the associative rule of multiplication. That is, Z1 into Z2 into Z3 is equal to Z1 into Z2, Z3. And multiplication satisfies the existence of identity. That is, in complex number we get the identity, multiplicative identity, that is 1. So we can write 1 is equal to 1 plus I0. So 1 is the multiplicative identity. When we multiplied by 1 with any complex number z into 1, then we get z. So 1 is the multiplicative identity. Similarly, complex numbers satisfy the existence of multiplicative inverse. That is, if z is equal to a plus ib and 1 by z is called the multiplicative inverse. That means z into 1 by z is equal to 1. So the value of 1 by z is equal to a by a square plus b square plus I whole into minus b by a square plus b square. So 1 by z is called multiplicative inverse of z. Let us discuss the division of two complex numbers. If z1 is equal to a plus ib, z2 is equal to c plus id. We will define here z1 by z2. We have already discussed z2. If z2 is a complex number, then 1 by z2 is multiplicative inverse of z2. So here we can write this z1 into 1 by z2. If z2 is equal to c plus id, then 1 by z2 is equal to c by c square plus d square plus I whole into minus d by c square plus d square. Now we will find z1 by z2. So z1 is equal to a plus ib whole into 1 by z2 is c by c square plus d square plus I whole into minus d by c square plus d square. Okay. We have already discussed z1 into z2. If z1 is a plus ib, z2 is c plus id, then z1 into z2 is equal to ac minus bd plus I whole into AD plus BC. So now we'll put this formula here. So I get AC A into C by C square plus D square minus BD. So minus B into minus D by C square plus D square. So here we get the real part of Z1 by Z2 plus I whole into AD. A is A here into minus d by c square plus d square plus b into c by c square plus d square. Now we get the value of z1 by z2 is equal to ac minus plus ac plus bd by c square plus d square plus I whole into bc minus ad by c square plus d square. We get the real part of z1 by z2 is ac plus bd by c square plus d square, and the imaginary part of z1 by z2 is bc minus ad by c square plus d square.